We basically we wanted to. Let me go back to here and get to the exact number. This is 14.4.2, and A and B should be the same, right? No, after you did A, it's just this part B is the same basically. To show that actually one is given by the contour in the as in the text. That this is basically C sub 1, right? And then we do the x over 2 t minus 1 over t dt t to the minus nu plus 5. That's why like a product instead of division, t to the minus nu plus 1 or minus nu plus 1. Right? dt. Right? We want to operate h with the Bessel equation, differential operator, which is right, should be in section 1. That is that up. You don't want to make a mistake. Just not having the correct operator. Operator is x squared d squared dx squared plus x dx, right? And then plus x squared minus nu squared, and so that that is your differential operator. We want to show that this operates on h, basically because it's an operator in x, so it take the operator on the integram, and let's call the give a label of the integram. So this is integram I, right? We want to show that this is to show. We want to show the L operator on I equals to. Let's look at the question again. Oh, actually, in the question, actually in the text, I want to show that this equals to a total derivative with respect to t, the integration variable t of this quantity in equation 14.89 exponential. This is t minus nu, and exponential function 2 minus 1 of t, and multiplied by nu plus x over 2 t plus 1 over t. Right? That is what we want to show, right? This operator on that. If you get it to a total derivative, so this will go to a total derivative. The whole thing will be a total derivative, and the argument will be that the contour c sub 1 is we actually need the c sub 1 in the asymptotic integral. So we have a branch point and a branch cut to the negative infinity on the t plane. I mean along the wheel axis, wheel line. So you go a little bit toward the positive wheel axis and then turn around, go to the branch cut, above the branch cut to negative infinity. So that's c sub 1, right? But the argument is just we already argued that if this is true, then the L operator on that, this give you this one. So the integral will be this quantity evaluate at the end point minus the initial point, and at both points, this quantity will be 0. So at the large t, so this term will give you a exponentially small. For small t, t equals 0, this term will give you exponentially small. Right. So that's the argument. And now the step, the missing step is to show this one, right? And there's no magic to that. You just need to struggle with it, right? And see if you can reproduce. Then you do it term by term. You basically do it term by term. So keep taking derivative because we need first and second derivative, so we need di dx. And I is this one, so you have this one, right? It depends on x, so it's basically the same exponential function, and then take the derivative of the argument. The derivative of the argument is just copy the argument, right? Yeah, that's this. So sometimes it's easy to confuse. Okay, so that's correct. Oh, no. Say that again. Do not.
So
I is just the integram. I has defined the integram as I, because I want to show that the L operator on integram give you total derivative. This is still in the integram. Okay. Okay, that's more like it. And now we need the second derivative, so we take the derivative again. So d squared I dx squared equals to, again, exactly the same x dependency, right? And so you have 1/4 t minus 1/t squared, and everything got this copy. Okay, and then we have so if we multiply by x and multiply by here, multiply x squared, and here we get these two terms. Now we have two more terms. One is x squared multiplied by I, the other is nu squared multiplied by I. And if I remember correctly, it will be easier to combine these two because both have x squared, right? So we have both, we will combine these two, x squared, t squared I, x squared plus I, right? This is a plus. That equals I is this one. So it has, so basically this is your I, right? And then you have 1/4, basically 1/4 of that, this factor plus 1. And now you use the trick that this plus 1 is basically just changing the sign of this one, if I remember correctly. So you can work it out separately. So 1/4 of t minus 1/t squared plus 1 is 1/4 t squared minus 2 plus 1/t squared plus 4, right? This one equals this one. So basically you use 2, this 4, you can use the 4 to change the sign of this one. That is 1/4 for this. Okay, is that okay? Sure. So combining this has this simplification. It's basically just flipping the sign of this term. T plus 1/t squared exponential function. That's an x squared, because we multiply by x squared. T minus 1/t e to the minus nu plus 1. All right, and now one one trick you can say is a trick, but it's not actually a trick because you want to uh, now start to make time DDT. Well, this is not time, this is just time derivative. You look at this, what you finally want to get is you have this t plus 1 over t factor, and you got this t plus 1 over t factor here, but square. You can use one of the factor and combine with that to change this to a ddt of this one, because no, this is just our work area. Okay, you got this, right? So, yeah. So let's see what we'll get. We get ddt of exponential function equals to the same exponential function and take the derivative of t. Now it's really take a t would be x over 2, 1 minus, and the minus 1 over t squared, so plus 1 over t squared, and the same exponential function. Right? You got this, right? Good. You take the derivative of this one, give you this. The argument of the exponential function. And then this you can put in the form of t plus 1 over t by pulling out a t, x over 2t, t plus 1 over t, t over 2. Okay. So you can use one of these factors. So this times that is one of the factor, this times this one, and then x over 2t. You have x over 4, so use x over 2 here, and then divided by t, which is, yeah, you have a divided by t here, so you have minus 1, right? So altogether, you can write like, you get x over 2, so the rest is x over 2. You take one factor, so one factor is left. And you take this minus 1, so you only have t to the minus mu. And the rest is this one. Okay. Now you begin to see the similarity. So this is, you have t to the minus nu, t to the minus nu. Now you take the derivative over this factor, which is this one. And then you multiply by x over 2, t plus 1 over t. So this basically this one times this one, and take a derivative of this one. So these two terms give you this. Okay, you can see that. So far so good, right? So we just need to combine. So we are taking care of this term and that term. So we still need these two terms and see what we get. So let's consider this term x dx. Now as x over 2. Now you have t minus 1 over t into the minus u plus 1 exponential function. Now the idea you want to get to something similar to here, and one thing you can do is again use this minus t to the minus 1, so basically it's divided by t, so you change that. I'm erasing thing because I don't have enough space. The minus nu divided by t, so this is 1 t squared, right? And then now this one is easier. You probably don't need the work area. This is just now copy the rest. X over 2 e to the minus nu, the exponential function. And this is just ddt of e plus 1 over t. Right, this one is just, you see that this factor which I got from dividing this by t, so you get this one and equals to this one, right? You can see that, right? I mean, each step is important. It's just basically this is to convince yourself this is true. So, right? dt will give you this one. Now, now this term will give you. Now you look compare back to here. Your x over 2, e to minus new exponential function, and now you're taking the derivative over this one. I mean, you can combine this is x. You can combine this to this and take the derivative of this one and multiply by the rest. So far so good. So and then you have one final term left, minus mu square. I still have space, hopefully some space here. And you have minus mu square I. Now this one. This one, see, this basically multiplied minus mu square. Let's copy it first, minus mu square. And you have t to the minus mu plus 1. And the exponential function. And you want it to be you want to make it to a derivative also, but this is nu square. You actually want to get a nu, but you can get a nu out by just take a derivative. So this is equals to minus nu. One of the nu is coming from ddt of t to the minus nu, because minus nu we pull out a minus, so you probably change the sign here, right? You take ddt of t to the minus nu, pull out minus nu, become minus nu square, and then becomes t to the minus nu minus 1, which is this one, right? So now let's say exponential function. Okay, so this term is compared to that. This is the derivative. This term, this operator on I is the derivative of this one, and keep this fixed. Right. Now see if we have everything. Yeah. Basically, we need to combine all 4 terms. I combine all this. See if we got everything. Because we want to get the total, this equals the total derivative. So when you take the total derivative, you have t in here, t in here, and t in here, right? Right. So the first derivative over this factor is this dt is exponential function multiplied by nu, but then there's another factor, another factor, which is seems like we're missing this one. Right? So, are we missing this one? Let's see what we have. So, this 2 term is this thing. Let's take the derivative of this one and multiply by t to the minus nu and multiply by x. So we didn't have this one. So so we still need this one. So when we still need to take a derivative of this multiplied by nu, right? Nu t. This one we don't have, and but this one you have For this one, you have take the derivative over this one, or you can combine this two because this is a constant. This is like taking a derivative of the whole thing. You can combine x over 2 in here and plus nu. So take a derivative of this factor and multiply by the rest. So you have this one. So take a derivative of the first factor. You have that one, and keep the rest. This is just taking the derivative of this factor, and then multiply by just nu. Just this, take a derivative of it, then this multiply by nu, and we don't have that. And it's the two cancel. So we need one. We need, because this one is missing. This one is missing. Taking a derivative of this one, and then we have multiplied by this one, but we don't have that. We don't have this one. We don't have this one. So yeah. One thing is to do is what we are missing is or alternatively we can write it down explicitly and compare with this and see what we got. Okay, right, so that's what we'll do. Here we got all this, and so there's a chance that whatever is missing here cancel. There's missing one term, and there's missing the other term. So let's see if this derivatives. So this one is first you take the derivative over this one. So the first factor is ddt. T of e to the minus nu, which is this one. This exponential function. And multiply by this factor, mu plus over 2 e plus 1 over t. So that's this factor, and then plus get enough space here. Plus the this right here, plus the taking the derivative of the exponential function. Now we give you x over 2, 1 plus 1 over t squared, and then multiply by t to the minus nu, and the same factor. Oh, no, missed the exponential function. To take the derivative of the exponential function, you need to copy the exponential function, and then this factor.
The x over 2 that we have.
Which one? This one? This one is taking, this term is taking derivative over this factor. This term is taking derivative over this factor. Yeah, take a derivative over this over t. So you have x over 2, and then derivative of that, you 1 plus 1 over t squared.
I was thinking in terms of x.
Yeah. Now this is the alternate, the right hand side. The right hand side derivative over t. Okay, and then finally this the other factor t minus nu exponential function. And then take the derivative of that, give you x over 2 t minus 1 over t. Okay, that should be it. So this is the right-hand side. Combining all three is the left-hand side, right? It's okay. So all this, it is plus that is the left-hand side. And now we see we have cancellation, right? And the first term here basically is we'll take the derivative of that one. We'll take the derivative of that one. Basically give you this one, because you have a t plus 1 over t, right? Which you have x over 2, which is this one. When you take the derivative of that, you get this and that combined. This and that actually the derivative of that one, right? ddt. This is exactly what we did. ddt of this is x over 2 multiplied by this, multiplied by exponential function. And then you have this t to the minus 2. So this term on the left-hand side cancel with this term. Right. Hopefully we are making progress. Okay, second one, x over 2, this one, this ddt over this one will give it this one, and the x over 2, t to the minus nu, the same exponential factor, right? The same exponential factor. But no, I'm comparing the wrong thing. I should compare this with that. You have x over 2, e to the minus nu exponential factor, and this one is basically yeah. Well, when I take the data, I think I got it wrong. That's 1 minus d squared. Or you can just say this is ddt of this one, which is exactly this one. Right? Compare with the third one is take a derivative of this one. So but this one is exactly x over nu t the minus nu exponential function. ddt of that is 1 minus 1 over t squared. This term cancel with the third term. Okay. So far so good. You can follow me like hopefully. So now this one is ddt of this one and the exponential function, right? And then multiply by nu. So basically is this factor ddt of that exponential function and nu. So this one, I have already, so this one, whatever I use, this one cancel with this one. And whatever is left is this two, this one and that one. So let's see whether these two cancel, because that one has a t to the minus. I need to work that derivative out. So this is minus nu t to the minus nu minus 1. So you have 1 over t. I use that to cancel with the t. We have x over 2, 1 plus 1 over t squared. So divided, when I take the derivative of this one, I have a minus 1, right, which is divided by t. I divided by t over this factor is 1 plus 1 over t squared. Right? And copy the exponential function. Get still some space. T minus 1 over t. It's the same exponential function. Okay, now let's see if this is the same as this one. you have a nu t to the minus nu, your x over 2, 1 plus 1 over t squared, and the exponential function. Okay, and this is positive, this is negative. Right? Okay, I should say that's what equals this plus this term plus this term equals 0. Okay, so we cancel everything. So we show that this is correct. It's a long struggle. Can you follow everything? If not, then maybe look at the class video later and then see if you miss any step. Right? I mean, it's just a brute force. Maybe there's a more elegant way to do that, but I haven't figured it out.